Okay, we're continuing now on number 25, section 9.6, solving rational expressions. Now, kind of funny, a few minutes ago I solved one and I made a mistake, and I forgot to multiply the 7 into the problem. I had to erase the film and redo it again, but we're okay though. Everybody makes mistakes, so let's get started. So again, the primary thing you want to do here is factor the denominator. Now, can you factor anything out of here? Well, we can factor a 1 and a 1 from there, but we don't factor 1s in algebra. If anything, we'll factor a negative 1, but we're not going to be factoring 1s because it doesn't do anything. It doesn't accomplish anything. So since you can't factor anything, I'm just going to go ahead and put the parentheses around there. Okay, now here I have 2 times x. So the way I'm going to factor this, I'm just going to go ahead and put parentheses around them. So we have a 2 times the x. It just makes it a visual, like we're really doing something. And then we can't factor anything out of this x, so I'm just going to put a parentheses. As we go on and the problems get a little bit more difficult, there'll be a little bit more factoring going on. Right now, it's not that difficult right now. So, we need to make, these have already been factored, or they really don't really factor at all. So we're now going to make an LCD list. So there goes, LCD. Now I'm going to get a sample of each denominator. So my sample here would be x plus 5. Sorry, x plus 1. My sample that I'm going to get from this guy will be 2 and an x. So I'll put a 2 and an x. And the sample I'm going to get from here is an x, but I already have an x. So there's no need to put another x if it's already there. We're only getting samples as long as they don't repeat. Then we'll be fine, okay? So let's continue. Now I'm going to multiply every term by the LCD. We have 3 terms. Term 1, term 2, term 3. I'm going to multiply every term by the LCD. So there goes. I'm going to multiply this by 2x times x. That doesn't look too good. I'm trying to make sure it fits in the front because it makes it better. 2x times x plus 1. I just barely made it fit. And here we have 2x times x plus 1. Here I'm going to put it in the back. 2x times x plus 1. I multiplied every term by our LCD. So remember again that we are not trying to multiply this, the numerator, our LCD with the numerator. We're not trying to do that. The whole purpose is to cancel the denominator. And if you look closely, we have an x plus 1 over an x plus 1. So those are going to cancel. If we look over here, we have a 2 here. Cancel with the 2 here. We have an x here that cancels with an x here. And over here we have an x here that cancels with that x right there. So it looks like we've gotten rid of our entire denominator, which is perfect. Exactly what I want to do. So I'm going to multiply what we do have left. So we have 2x times 3x. So 2 times 3 is 6. Very good. So it'll be 6. X times x would be x squared. And what do we have left? We have a 6 times x plus 1. I'm going to go ahead and take advantage, and I'm going to go ahead and distribute that 6 in right now. So we're going to have 6 times x would be positive 6x. 6 times 1 will be 6. There I just distributed that, which basically means multiplied. And then I'm going to go to put the equal sign. Now here I have a 7 times 2 gives me a 14. So 14 times x gives me a 14x. And a 14 times 1 gives me a 14. Okay, so we're in good shape here. We're in pretty good shape. Now, the next step we're going to do is we're going to go ahead and get all of these terms and get them to this side. Okay, because we want to have everything in standard form. And standard form would be having, first of all, everything on one side, and having the x squared, then x to the first, and then x to the 0, which you don't ever see the x to the 0. So let's get started. I'm going to get rid of this positive 14x by subtracting 14x. Now, let me quickly put that line I've been putting lately. You do it to the right, and you do it to the left. Notice I conveniently put it underneath the other x. Okay? Now I'm going to get rid of this 14 by doing a subtract 14. You do it to the right and you do it to the left. Notice I put it underneath the other constant because I'm going to be subtracting it with it. My line's a little crooked. I'm going to do it one more time. I know that, there we go. That's a lot better. So, if you look closely, 14x minus 14x cancels or simplifies out. The 14 minus 14 also cancel. So what's left on the right? What's left on the right, we talked about this also previously, was we're left with 0. You do have to put something there. Okay? So now I'm going to write the 6x squared here. And then if my variable is identical, I write it once. Right here we're combining like terms. If the variable is identical, you write it once and do the math. And what is 6 minus 14? When the signs are different, you subtract, keep the sign of the bigger number, so the bigger number will be negative. So we're going to have 8. That'll be 8. Because 8 plus 6 will be 14. Now here we have kind of the same situation. The bigger guy is negative, so I'm going to go ahead and put a negative again. The signs are different, so I'm going to subtract and keep the sign of the bigger number. So I'm going to keep the 14, it'll be an 8 again. Okay, it looks like we have ourselves a little quadratic now. But it looks like we can divide something out of each term. Can you guess what we can divide? Take a look. What can you divide here, here, and here? If you said 8, that would be correct because you can divide 8 here, but not here. If you said 6, you can divide 6 here, but not here and not here. But if you said 2, then you'd be 100% correct. I'm going to be dividing by 2. I put a negative by accident. Be dividing this by 2, this term by, I keep feeling I put a negative, 2, and I'm going to divide this term by 2. Every single term has to be divided by 2 in order for this to be legal, or however you want to call it. So, now, it's time to write the answer. 2 goes into 6 3 times. So we're left with 3x squared. 2 goes into 8 4 times. So we have a negative 4x. And 2 goes into 8 again 4 times with that negative in the front. So we're left with the negative 4 is equal to, and again, 0 divided by 2 is 0. So now we have ourselves a quadratic. It is in standard form. So we're going to go ahead and, remember there's 3 ways to solve a quadratic. Number 1 would be to factor and solve using the zero product property. The second would be using the quadratic formula. And the third would be completing the square. We're going to do factoring. This should work. I hope it works. I haven't tried it yet, but let's give it a shot. Okay, so here the 3 has factors of 1 and 3, 3 and 1. Okay, so now we're going to do here, we're going to factor the 4. So the 4 is going to be factored. So we're going to have a 1 times 4, a 2 times 2, and a 4 times 1. Now notice they start to repeat there again. So when they start to repeat, you can get rid of one of them. So it looks like I'll get rid of this one. I'll get rid of this one. Because after it repeats, you only have to put the repeats on one side, not both sides. So there goes. We're going to start multiplying the outers and then the inners. So we have 1 times 4 is 4. 1 times 4 is 4. 3 times 1 is 3. Can that add? If you add that, I get 7. If you subtract that, I get 1. We're not getting the negative 4. We're trying to get a negative 4. So by multiplying the outers and the inners, we're trying to either add them or subtract them to get that 4, and we're not getting it, not with that. So I'm going to go and put a check mark there. So we've tried that one already. So let's try it again. Now we're going to try the first one with the second one. We have a 2 and a 6. 1 times 2 is 2, and 3 times 2 is 6. If I subtract them, I get 4. And even better yet, if I put the negative in the front of the 6, I get negative 4. That matches perfectly. So it looks like we found exactly what we need to do our factoring here. So we're going to go ahead and get started, or continue. So I'm going to go ahead and put my factors here. My first factor, second factor, and it is going to be equal to 0. Bring down this equal sign, bring down the 0. I'm going to put a 1 here. I'm going to put a 3 here. I'm going to put a 2 here. I'm going to put a 2 here. Okay? Now, I have to put an X here, and I have to put an X here. Now, if that's a negative, that means that these signs are going to be opposite. One's going to be positive, one's going to be negative. If it were to be positive, they'd be the same. But being that it's negative, they're going to be different. So we do have to kind of try to figure out which one it's going to be, but we have to experiment. So I am going to try, and I'm going to put a negative there, I'm going to put a positive there. Again, we don't need this 1, so I'm going to erase this 1. So there it goes. 3x times negative 2 is negative 6x. 2 times x would be 2x. And if I combine those, I will get negative 4x, which is exactly what I have in the middle. So now, I don't even know if you can see that negative 4x in the bottom. So I'm going to put a little arrow that says I'm going to go and continue the problem right here. And I have a little bit of room there. Maybe I shouldn't go so far out so I don't push myself out of the camera's range. So I'm going to go ahead and rewrite this. X minus, it's going to be x minus 2. And we have a 3x plus 2. And we're going to put it equal to 0. Now I'm going to quickly check the camera to make sure it barely fit. Okay, so we're okay. So now the zero product property says that if this is 0, 0 times anything is 0. Or maybe this can be 0 because 0 times anything would be 0. Or maybe they're both 0 because 0 times 0 is 0. That would be the zero product property. So I'm going to go ahead and assume that they're both 0. So I'm going to make them equal to 0. So I'm going to put x minus 2 is equal to 0 for that guy. Same with this. 3x plus 2 is equal to 0. Now I have my two little equations here. I am going to get rid of that negative 2 by adding 2. And I'm left with x. Oh, what mistake did I do? I did it to the left, but I forgot to do it to the right. Okay, we're good now. So my 2's cancel. I'm left with x is equal to 2. Here's my first solution. And then over here, again, I'm also going to get rid of the 2 by doing a minus 2 to the left, minus 2 to the right. They are going to cancel. I'm left with a 3x is equal to negative 2. Negative 2 is a little ugly there, but that's okay. Whoa. Here I'm going to divide by 3, divide by 3. So now my x is equal to negative 2/3. Let me quickly check the book. And the book agrees with me. So we're done with this problem, number 25. If you have any questions, you can always fast forward and rewind to see the problem. Thank you.